Hi everyone. In this video I'm going to demonstrate how to perform multi-level binary logistic regression using Stata's drop-down menus. Before we get started, let me note that underneath the video description you will find a link to the Stata data file that I'm using so you can download the data to follow along. Additionally, you will find a link to a PowerPoint. Now in this presentation I'm going to focus mainly on the procedural aspects of performing the analysis using the drop-down menus, and the PowerPoint goes a lot more into detail concerning interpretation of the results. So be sure to download that to learn more about how to interpret these results that we're going to be generating. So the example we are using is based off a presentation by Summit and Mercelli in a 2018 article on multi-level logistic regression. And in that particular article, the authors analyzed a fictional data set containing students that were nested within classrooms. So they were essentially examining two predictors of the probability of a student owning the Justin Bieber album Purpose. So the binary outcome variable is this Bieber variable right here. It's coded 0 for does not own the album and 1 for does own the album. And the level 1 predictor of the outcome variable was GPA centered at the classroom mean. And then the level 2 outcome, this was level 2 predictor, which was a classroom level predictor, is this teacher fan variable. And for our data, for our analysis, it's coded 0 and 1. Basically 0 indicates that the student's teacher is not a fan of Justin Bieber. A 1 indicates that the teacher is a fan of Justin Bieber. In their original demonstration, they used an effect coded predictor where they had a teacher fan variable that was coded -0.5 and 0.5, but we're going to focus on just using a dummy coded predictor in this particular demonstration. So it's not going to follow along exactly with their demonstration. Additionally, we're just going to demonstrate 3 models rather than the full set that they demonstrated in their article. So the first model that we are going to demonstrate will be an intercept only model. And basically what we're doing with this particular model is attempting to determine if there's significant variation across classrooms in terms of the average of student logits. So in the context of binary logistic regression, the outcome variable, which is the probability of a target event, which in this case would be the probability of owning the Justin Bieber album Purpose, has to be transformed into a logit. So essentially you can think about logits as an indirect way of modeling the probability of an outcome. And so what we want to do is to determine if the classroom average of students' logits, if those vary significantly at level 2. And so if the variance estimate is significant, then that would give us an indication of potential clustering in the data. And as with any multi-level procedure, the reason why we start off with this intercept only model is to determine if we have within group dependence of observations, and if there is dependence, then that would actually justify the use of a multi-level as opposed to a single level approach. Now the second model that we will be testing will be this one, where we have essentially our level 1 and level 2 predictors added into the model. And then for the last model, we will just simply allow the slope for GPA to randomly vary across the classrooms. So let's go ahead and open up Stata. As you can see right here, I've opened it. And what we're going to do is we'll take a quick look at the data editor. So we'll go under here, and you can see that our first variable right here, this is the student identifier, and this is our class variable. This is our level 2 identifier, and so students again are nested within classes. Our outcome variable is this Justin Bieber album, our indicator of whether a student owns the Purpose album, again coded 0 for does not own, 1 for does own. We have the level 1 predictor, which is GPA, and then we have the level 2 predictor, which is this teacher fan variable. So to generate the results from the intercept only model, what we will do is go under statistics, then binary outcomes, and then multi-level logistic regression right here. So we'll select as our dependent variable Bieber, and then we will next we will select create right here. So notice that on this first screen we are not including any independent variables, and that's because the intercept only model is does not contain any predictors. It's only the intercept. So at this point, under equation 1 right here, this box, we're going to select classes, which is the level 2 identifier. And then you'll see that down here we've got the variance covariance structure of the random effects selected, we've selected the independent covariance structure. And basically what's going to happen is that this is going to generate the variance estimate for the classroom intercepts. So next we will select OK, and then OK again in order to generate our results. So here you can see our results. First off, you will notice that in our table, it's got our Bieber outcome. It's got, this is the constant, and this is essentially the grand mean of the classroom intercepts. So that's the coefficient estimate right there. And down below you can see that we have the variance estimate. So this is the estimated variance of the classroom intercepts across level 2 units. And then down below you can see we've got the LR test versus logistic model right here. So this is a chi-square test, and this is essentially testing whether our current mixed model that contains the randomly varying intercepts, if that is a significant improvement in fit versus a single level model with no random intercepts. And so if this test is significant, then that would be an indication that incorporating the random intercepts represents a significant improvement in fit relative to that single level model that I was telling you about. Again, I'm just kind of blowing through this, but if you download that PowerPoint, it goes into a lot more detail concerning what all of these things mean. So again, be sure to check that out. So if we want to generate odds ratios, I can show you how to do that as well. So if you go down to multi-level logistic regression, if you go under reporting, there's an option here. It says report fixed effects coefficients as odds ratios. So that's this box right here. So if you want to take a look at what this would look like in the current intercept only case, we'll just click on OK, and you can see that now our table contains the odds ratios. So this is it right here. And so basically this would be an estimated odds for essentially the average student in the average classroom. And basically all the other results related to the variance of the intercepts in the LR test versus logistic model are exactly the same. So next, what I will show you is how to generate the intraclass correlation coefficient. So in the context of multi-level modeling, what we're trying to do with the intercept only model is to determine whether we have evidence of substantial clustering in our data. And so if there's not really any evidence of clustering, then that would lend support for the use of a single level as opposed to a multi-level model. So one indication that we found so far is that LR test versus logistic model, that chi-square test is indicating that a model that contains randomly varying intercepts fits significantly better than a single level model where the intercepts are not randomly varying. So that's one piece of information, but we can also look at the intraclass correlation coefficient. So to generate that, we'll go down and use the post estimation command right here. And then under other reports, we can select estimated intraclass correlation. So if we double click on this, you can see it's already highlighted in our post estimation box. So we can click on OK, and now we have the intraclass correlation coefficient that has been estimated right here. So it's 0.279. So Heck et al. In their book, they kind of talk about kind of conventional thresholds for what indicates substantial clustering. A conventional threshold is about 0.05, but other authors really kind of go more into detail about, or at least mention that any amount of clustering can alter the inferences that you make, or the accuracy of your inferences. So you can see right here that our 0.279 is well above 0.05. So we have again evidence of substantial clustering in our data. So our next analysis, we're going to add in our two predictors. So I'm going to go back and binary outcomes again. multi-level logistic regression, and in this particular case what we'll do, also I'm going to, under reporting, I'm going to deselect this for right now, and our independent variables, I'm going to select our teacher fan variable and then our GPA CMC variable right there. So now we're adding in our predictors, and we're going to leave our equation 1 at level 2 exactly the same as before. Now I do want to mention that our teacher fan variable is a binary variable, but it's permissible to include this as treat it as a continuous variable in the actual model. If we wanted to treat it as a factor, then we could easily make it such just by using the I dot prefix. And what would happen is that anytime that you have a variable that's being treated as a factor, then using the I dot prefix will result in Stata generating dummy variables for the analysis. But I'm just going to leave this alone. I'm not going to treat this as a factor. I'm just going to leave it as a standard binary predictor, and then kind of having it included as a continuous variable in this particular analysis. We'll go ahead and click on OK and look at our results. So now you can see there's several pieces of information to kind of pay attention to. First, you have this walled chi-square right here, which is essentially, in this case, it's a test of the null hypothesis that the regression slopes for your predictors are all 0. So if this test is significant, that's an indication that that would lead you to infer that at least one of the population regression slopes is non-zero. Under our coefficients table right here, you've got our regression slope for teacher fan and then for GPA CMC. Now the regression slopes are expressed in terms of predicted change in logits per unit increase on the predictor variable. So it's not very intuitive when it comes to talking about probabilities, but you can basically think about it this way, that if the coefficient is positive, that means that that a person with a higher value on a predictor variable is more likely to exhibit the ownership of the Justin Bieber album than a person scoring lower on that particular variable. So a positive coefficient, you can just interpret it as that with higher scores on the predictor, that there's a higher probability of the target event than basically scoring lower on that predictor. If the coefficient is negative, that would indicate that a person scoring higher on the predictor is less likely to demonstrate to fall into the group, the target group, whereas a person that's scoring lower on that particular variable would be more likely to fall into the target group. So you can see both of these regression slopes are positive and we have statistical significance. So in a nutshell, what that indicates, if we look at GPA first, that would indicate that students with higher GPAs were more likely to own the Justin Bieber album than students who were lower on GPA. And then the teacher fan variable, that positive coefficient indicates that students who were in classrooms where the teacher was a fan, those students were more likely to own the Justin Bieber album than students who were in classrooms that were led by a teacher who is not a fan. And once again, if we want to generate the odds ratios for this particular analysis, we'll just kind of run back through this and go under reporting. We'll select report fixed effects as odds ratios and click on OK. And essentially now that column that contains the odds ratios, you could interpret the odds ratios as essentially the predicted multiplicative change in the odds concerning ownership of the Justin Bieber album per unit increase on the predictor. So as you're looking at the GPA variable right here, we'll just start with that. What this would indicate is that with each increase, 1 unit increase on student GPA, the predicted odds of owning the Justin Bieber album increase by a factor of 2.0059. The teacher fan odds ratio would be interpreted to mean that students who were led by a teacher who is a fan, their odds were 6.07 times greater than the odds of students who were in classrooms that were led by a non-fan of Justin Bieber's. Okay, so next what we'll do is we'll generate the ICC. So I'm just going to go back here and go down, use our post estimation command, go to other reports, and we'll click on estimated intraclass correlations, and you can see right here that it drops. Previously it was 0.279 and now it is 0.146. So you can see that by adding in our predictor variables that we have a reduction in the ICC. So we still have substantial clustering going on, but we do have a reduction in the amount of dependence shown in our data. So next what we'll do is we'll run the model that allows the slopes to randomly vary. So what we'll do is we'll go to multi-level logistic again. I'm just going to go ahead and select off of our odds ratios once again, and then just go to we'll select equation 1 and then edit. So we're going to modify our previous equation where we only had the randomly varying intercepts, and in this case we have selected right here the independent variables for the equation. So if we had a factor variable that we were treating the slopes as randomly varying with, then we would select the second button right here, but we're not. We are going to stick with the independent variables for the equation and then use our drop down and select the GPA CMC variable. So you'll again notice that this is our level 2 variance covariance matrix. Leaving it as independence, what we will have is variance estimates for the intercepts and the slopes. So the variance covariance matrix will be treated as a diagonal matrix, and so if we click on OK and then OK again, we can take a quick look at our output. Much of our results are the same, with some differences in the numerical values, but basically our fixed effects portion of the model is largely giving us the same results. Then under classes right here, you can see that we've got the variance for the intercepts, that's it right there, and then we also have the variance for the slopes, which is given right here. If we wanted a full variance covariance matrix where the off-diagonal elements are non-zero, essentially estimating the covariance between the randomly varying slopes and intercepts, then we can generate that very easily just by going back under edit here and selecting the unstructured option. So when we click on OK here and then on OK here, you can see that now we have our variance estimate for the slopes, for the intercepts, and then this right here is the covariance between the slopes and intercepts at level 2, and you can see we even have a significance test result that's given concerning the covariation between those two indices. So at any rate, that is pretty much concludes the walkthrough on how to perform multi-level binary logistic regression using the drop-down menus in Stata. Once again, I encourage you to download a copy of the PowerPoint which goes into a lot more detail concerning, it basically gives you the interpretations as well as the equations that are being used in our models. So that concludes the video, and I appreciate you watching.